Hello and welcome to today's class. Today we have this nice exponential challenge before us here. The question is 5 to the power of 2x plus 5 equal to 2 to the power of 5x plus 2. What is the value of x here? So we take our solution. Now we can use two methods to solve this, but I believe the first one will not work out. How? Here we are having the base to be a numerac, which is a constant, and the base here is also a constant. So we could as well just take the log of both sides of the equation to base 10 or ln base 10 on both sides of the equation. But if we do that, we're going to come up with this at the top and this at the denominator equal to the log of let's take 2 all over 5 or 5 all over 2. And so going to give us some challenge. So what we want to do here is just to rewrite the power here and also to rewrite this power here, or this expression alongside with the base. We just have to rewrite the applying the law of indices. Remember the law which says that if you have your a to the power of your m plus your n, this is equal to a to the power of m times your a to the power of n. So we go to this expression is what we have in this format, so we want to take it to this format. And so rewriting this is going to give us our 5 to the power of 2x, then times our 5 to the power of our 5, then this is equal to our 2 to the power of 5x times our 2 to the power of 2. Okay, so we want to take all the quantities having x to the left hand side and the ones without variable to the right hand side of the equation. So how are we going to do that? Yeah, we're going to divide through. Now you'll discover that if you simplify, you will discover that this, our 5 to the power of 2x is smaller than 2 to the power of 5x. And so we're going to divide through by 2x, and we divide through by this other side by 5 to the power of 2x. Then here we also have to eliminate this, so we also divide by times our 2 to the power of 2, then times our 2 to the power of 2 in here too. All right, so we discovered this and this will leave, then this and this will leave. So rearrange you, let's bring this to this side of the equation. So we're going to have 2 to the power of 5x all over 5 to the power of 2x equal to, here we're going to have 5 to the power of 5 all over our 2 to the power of 2. Okay, so from here, look at this. We can bring out our x here. So if we bring out our x, or we can rewrite this expression here. We know that if you have your k to the power of your m all over your p to the power of m, this is same thing as k all over p all raised to the power of m. So with that, we can separate this. Okay, so separating this is going to give us 2 to the power of 5 all over 5 to the power of 2 all raised to the power of our x here. This is equal to our 5 to the power of 5 all over 2 to the power of 2. So there is a reason why we still just want to keep this in this format. All right, so with this, if you check this, this is 2 to the power of 5. Here we have 5 to the power of 5. Here we have 5 to the power of 2, and here we have 2 to the power of 2. So there is no similarity between this and this. And so what we do here is just to ln both sides of the equation. So if we do that, this is going to give us the ln of our bracket open 2 to the power of 5 all over 5 to the power of 2 all raised to the power of x equals to the ln of 5 to the power of 5 all over 2 to the power of 2 close bracket. All right, so we continue. We apply the law of logarithm, which says that with your ln of your a raised to the power of b, we have to move this b this way to give us our b times the ln of our a. So if we do that, we are moving this x this way. So I have the x times, here we're going to have the ln of our bracket open 2 to the power of 5 all over 5 to the power of 2 equal to, here we have the ln of bracket 5 to the power of 5 all over 2 to the power of 2 close bracket. We're looking for s, so let's divide by everything here. So if we divide, we're going to have this to be equals to the ln of our bracket open 5 to the power of 5 all over 2 to the power of 2, then all over the ln of bracket open 2 to the power of 5 all over 5 to the power of 2 close bracket. We just have to apply the simple law of logarithm again, which is called the division law of logarithm. We say that when you have your ln of your bracket open a all over your b, so this is equal to your ln, sorry, this ln, okay, let me write it well, okay, so this is the ln of your a minus the ln of b. So here we're going to apply that here and also apply that here. So this is equals to the ln of our 5 to the power of 5. Let's put this in bracket, then minus the ln of our bracket open 2 to the power of 2, then all over, we do same thing here, the ln of our 2 to the power of 5, close bracket, minus the ln of our 5 to the power of 2, close bracket. Remember the power law of logarithm again. So we're going to move this power back here, move this back here, this back, this back. So we're going to have our x, we end up giving us our 5 times the ln of our 5, close bracket, minus our 2 times the ln of our 2, close bracket, all over. Here we're going to have 5 ln of, that is times ln of r2, close bracket, minus our 2 times the ln of our 5 here, close bracket. All right, can we still simplify this down? Yes, we can simplify this down, but it's of no use simplifying this down beyond this, because we can impute this into our calculator to give us our answer straightforward. But if it is not given in numerical form, then it will either be in this form. So this is the value of our x that actually satisfies our exponential challenge here. Okay, if you find the numerical value and you put it in here, then it's going to give you an approximate value. So this brings us to the end of this class. Thanks for being there. See you in our next class. Bye.